So just to give you a basic review of trigonometry, normally with trigonometry, students, the most basic idea that we have to keep in our heads is this idea of what are the names of the ratios and what sides are involved. So in a right angle triangle, the hypotenuse is the side opposite the right angle. The opposite is opposite the given angle, and then the adjacent is the other one. And you need to make sure you know sine is over h, or opposite over hypotenuse. Cos is a over h, which is adjacent over hypotenuse. And you know that tan is opposite over adjacent. Now that's for a normal right angle triangle, but then in grade 11, what we also do is we extend trigonometry to angles that are bigger than a 90. So if you imagine this one is probably like 45, but if it kept going, it would get greater than 90. And that situation is handled by letting the triangle go into other quadrants. So that might be an angle of, say, 150. And so in this case, we have to be comfortable replacing the O and H and the A and H with an X, Y, and R. And that's something which you need to get used to, that the Y is going to replace the O, the H is going to be replaced by the R, and then the X replaces the A. And so you can think of any creative way you like to do that. I think of yo, for like yo, the slang word for Y and O, and I think of ax for like the A and the X. But you decide how you want to remember that. You can see here O, H, and A. So give me a thumbs up if that looks familiar to you, this idea of the definition of the trig ratios, and give me a thumbs down if that looks completely new or you're very unsure of that. Because that's the base knowledge that we need to come back to every time. Okay, so now that we've seen that, we need to apply it. And let's see how maybe we could apply that. Now, like I said to you, if the angle inside your triangle is greater than 90, it goes into a different quadrant. So I'm going to draw my quadrant here. And in trigonometry, we start with 0 over here. And if we have to go, for example, into this quadrant, and we say that's our angle, if the angle is, say, 150, we no longer make the triangle in this quadrant. We make it in the second quadrant. And what we now say is in this quadrant, this X over here will be negative, that Y will be positive, and the R is always positive. And so what we do is we use something called the cast diagram. And the cast diagram tells us where different trig ratios are positive or negative. So C says that cos is positive in this quadrant, and all other trig ratios in this quadrant will be negative. A tells us all trig ratios are positive in quadrant 1. S tells us all trig ratios except sine are negative here. Sine is positive in this quadrant. And then T says that trig ratios in quadrant 3, or between 180 and 270, and we put in the little values, tan will be positive. And so this is the beginnings of what we call the reduction formula, that actually all trig statements, so something like the sine of 150 can actually be reduced to positive sine 30. They're equivalent in their value. And we're going to talk a little bit more about that, but I just want to do some quizzes first. So if I say to you the sine of 210, is that going to be positive or is that going to be negative? Tell me if you think that's going to be positive or negative using the cast diagram or using what you know so far about trigonometry. So if we imagine the angle of 210, I'm going to go 90, 180, 210. and my triangle is formed in this quadrant. In this quadrant, only tan is positive, and so sine will end up being negative. Okay, so I'm just asking you about the sign for now, like positive or negative. Let's just do one more, then I'll move on. If I said to you, is the tan of 210 positive or negative? What would you say about that? Okay, and we can say it's positive because in this quadrant, tan is positive. Now, there is something else in this drawing. There are these 180 minus theta, 180 plus theta, 360 minus theta. And when we use the reduction formula, all we need to do is ask ourselves, how far away, after we've done whether it's positive or negative, so you've done the positive or negative part, we ask ourselves, how far away is this trig ratio from the nearest horizontal? Now, if we look at sine of 210, what is the nearest horizontal line to 210? Let me know in the chat which horizontal line is closest to the sine of 210. So what horizontal line? If you think of 210, it's in quadrant 3. I think it's going to be this horizontal line. So what horizontal line is closest to the angle of 210? I think it's the one I just colored in yellow. What's the equation of that line? It's 180, yes. Now, how far away is 210 from 180? So we're almost asking, like, what is the size of this angle? Because we've gone 180 to get here, and it's 30 away from the nearest horizontal. And so what we say is, in this quadrant 3, we always rewrite the expression in terms of this formula. So we can write sine of 210 as minus sine of 180 plus theta. And once we've rewritten it as 180 plus theta, we can then reduce it to minus sine. Sorry, that shouldn't be theta, that should be 30, because we know what it is. This should be minus sine 30 if I use the reduction formula. Now, the same thing is going to happen with the tan of 210, except I'm going to rewrite that as the tan of 180 plus 30. And then when I reduce it, I'm going to get positive tan 30. And that's what we call the reduction formula using the horizontal. We have reduced these angles using the nearest horizontal. We rewrite them in terms of the nearest horizontal. And then when we reduce, we can literally just drop, this drops away. Why plus 30? Because the angle that you were given was the sine of 210. And if you want to get to 210, you would have 180 plus 30 to get to 210. So the plus 30 came from this idea. Let's do another one like this, orokinesis, so you can see how this works. If I said to you, I want to, what is the tan of 150? If I wanted to visualize that angle, visualizing it, to visualize 150, I would be in this quadrant. Is the tan of 150 going to be positive or negative? Tell me in the chat. Okay, it's going to be negative because it is in the second quadrant where tan is negative. Now, I'm going to rewrite this. How am I going to rewrite this next bit? Am I going to write 180 plus 30 here? That wouldn't make any sense. What should I do instead? I should write 180 minus 30. Yeah. And now, because of the reduction formula, I can write this as minus tan 30. Because this is telling us how far away is this from the nearest horizontal. It's just 30 degrees. Notice how the reduction formula in quadrant 2 is 180 minus 30. Let's do one more because I can feel like you guys are remembering this now. So if I said to you, is the sine of 330 positive or negative? What would you tell me? Now notice how I'm dealing with a different angle now. So is it going to be positive or negative if I say to you the sine of 330? Well, let's try and visualize it. So that would be 90, 180, 270, 330 would be somewhere there. So because it's in this quadrant, it's going to be negative. And I'm going to write sine. But now what am I going to write inside this space over here? What am I going to write inside this space over here? I can't change the angle, but I want to use the reduction formula. So I go 360 minus 30. Yep. And that's because that will be the same. 330 is the same as 360 minus 30. And then what's my last step going to be? It's going to be to reduce this to minus sine 30. So what I've been doing there is I've been showing you what's called the reduction formula of the horizontal. And that's probably the most common reduction formula. You can use co-functions and you can use other types of things, which I'll go into later. But for now, that's the most common idea. Give me a thumbs up if that made sense to you. Give me a thumbs down if it didn't make sense. Just want to get a feel for the room. Okay. Awesome. So it's always nice when you come back to it and you sort of start to recognize stuff maybe that you didn't understand in class. So some of the things that you need to think about are converting negative angles to positive angles, which is actually not that hard. I'll show you in a moment why. Reduce angles greater than 360, use reduction formula, and use co-functions. Now, co-functions, instead of using the horizontal lines, we just use the vertical lines, which will be 90 and 270 for the co-functions. And we have to do it slightly differently, but I'll get into that during the lesson. Now, I don't learn these formulas off by heart, but you can kind of see why everything in quadrant 2 would have that structure. Everything in quadrant 3 has that structure. This is going to be quadrant 4, and then this would be quadrant 1. And this is just negative angles. So this would also be quadrant 4. So this is just the reduction formula applied. I'll do one negative angle to help you. So imagine I said to you, what is the sine of minus 60? Now, if I want to visualize minus 60, what is different to say the sine of 60? Who has an idea about what's different about the sine of minus 60 compared to the sine of 60? What do I have to draw differently? So you need to go for a negative angle, you need to go in this direction. So if you imagine that this angle gets me in this quadrant, is the sine of minus 60 going to be positive or negative? What do we think? Well, because it's in quadrant 4, it's going to be negative. Now, how far away is this minus 60 from the nearest horizontal? Now, my nearest horizontal is that, and it feels to me like this is 0 degrees. That's 90, that's 180, that's 270. How far away is minus 60 from the nearest horizontal? What's the size of this angle here? Or another way of writing it, you could also write it like, okay, it's actually going to be 60 away. So maybe you could write it like this. If I wrote it as 0 minus 60, can you see that? Okay, I'll tell you what. the easiest way to do negative angles is just to say, how far away is it from the nearest horizontal? It's actually just going to be 60 away. And so you can write minus sine 60. Okay, iPhone, I see you've raised your hand. Do you want to unmute iPhone and we can go from there? Can you hear me, iPhone?
Hello, sir.
Hey, how can I help?
So since like it's in the first quadrant, so can't it be positive? Since like
Okay,
all
but
the things in the first quadrant are positive.
okay, here's the thing though. It's not in the first quadrant when it's a negative angle. So the first quadrant would be, let me illustrate them. So here's the first quadrant, here's the second, here's the third, here's the fourth. So negative 60 actually ends up in the fourth quadrant. And only cos is positive in that quadrant. Does that kind of make sense? That I'm
yes,
going
it
the
does.
opposite direction. Thank you for the question. It was very helpful. A lot of students would have been thinking that.
I think so.
Okay, Tsigabatso, I'll deal with sinus. You know what? Okay, Tsigabatso was asked, what if it falls exactly on the line? I'm going to say to you, Tsigabatso, you can just put it into your calculator and you can see whether it's going to be positive or negative, or you can use a trig graph. But I don't want to go into that in too much detail right now. But the short answer is, if it falls exactly on a line like minus 90, 90, 180, or 270, you generally have to substitute like 1 or minus 1 or something like that in. And you can normally get that from your calculator. Okay. Now, what I want to look at here is what are the following triangles over here called? You may have heard about them before, but I want to know, maybe if you put your hand up, what are these triangles called? And what do they help us do? Yes, these are called special triangles. These are called special triangles, and they help us evaluate a trig expression without a calculator. So if I say to you, what is the value of sine of 45? And you can't use a calculator, you have to use this. What is the value of the sine of 45? If you look at that thing there, what do we think it is? How would we work it out using what we know about trig so far? I know that's an H, and that's an O, and that's an A. How can we use this to help us? So O over H is just going to be 1 over root 2, because O over H, piece of cake. Okay, well, what if I said to you, what is the sine of 60? Can you use this triangle over here still? No, because there's no 60, but you can use this one. So why don't you tell me, sorry, I'm doing this wrong. Why don't you tell me what the sine of 60 is without using your calculator? Yes, iPhone, let's unmute you there. What is your question?
So, but let's say the angle is in the is between the two adjacent sides, like the 90-degree angle. So
yes.
So which side would be the opposite and the adjacent if it's
okay? So as long as you can if you are dealing with 60, right, like we're doing now, the O will be opposite the 60. If I say to you, I want to know what the sine of 30 is, then the O would be over here and the A would be over there. Does that help?
Yeah, but so if like the angle is, you see where 90 degrees is, let's say it's just a triangle, and then in place of the 90 degrees, there's another angle. So which side would be the adjacent and the opposite then?
Okay, I'm not sure I exactly understand your question. I'm going to have to come back to it maybe a little bit later, because I kind of only half, and I'm hoping that it'll come up in another question and you can point it out to me. Okay, because I think I just want to explain this for now. It might come up in a later question, then we can get into a bit more detail. So for the sine of 60, we would get root 3, because it's O over 2. And if we were dealing with the sine of 30, well, then we have O here, and that would be A. So the sine of 30 would be 1 over 2. Give me a thumbs up if you followed that. Give me a thumbs down if you felt a bit unsure about how I was reading off the special triangles. Okay, now, what we like to do as teachers is we like to do a remix. So I'm going to say to you now, I want you to evaluate the sine of 225 without using your calculator. So it's a remix version. Who has some ideas for me about how I can evaluate that, but no calculator? So you can't go sine 225. You have to use other techniques you've learned about. What do you think we need to do? I'm open to people of the room. Give me your knowledge, people of the room. See which quadrant it's in. Okay, Trig, let's go to you. What do you think we should do?
Good afternoon, sir.
Hey.
I think we're gonna have to say sine 180 plus 45.
Okay, so we're gonna say sine 180 plus 45, and
it's gonna,
that's a reduction formula. Yep, and then
it's gonna be sine negative sine 45.
Okay, how did you know it was negative?
Because 180 plus theta is on the third quadrant, and on the third quadrant only 10 is positive.
Perfect. Okay, negative sine 45 gives us a reduced one. I'm gonna give someone else a chance for the next bit, but thank you, Trig.
Thank you, sir.
How do we get the next part? What is minus sine 45 going to convert to? So we've looked over here and we look at our special triangle and we go sine of 45 is just going to be 1 over root 2. And that is going to be that. Okay. I feel like we've got the basics of the reduction formula. And so we are okay there. I want to just do a little preview of a question like this before we go off to have our break. So, okay. Now in this question, it says if the tan of theta is this, and it's negative, and theta is between this, determine using a diagram the value of the following things. So I want you to draw the diagram that you think you may need to answer these two questions. And if you can't do it, just give me a thumbs down. Give me a thumbs up if you think you can draw the diagram that this information is asking about. And you can be honest, it's fine. We've got 10 minutes left, so we're gonna... Okay, I'm watching the thumbs. I'm seeing more downs than up. Okay, so let's think about this. If an angle is between 180 and 360, it has to be either in this quadrant or that quadrant, because 180 is here, 360 is here. So the choice of quadrants that are involved is going to be one of these two. But they also say that tan is negative. Now, tan is negative in this quadrant and in this quadrant. So what quadrant do you think I'm going to do my drawing in based on the math so far? on the information that I'm looking at here. Okay, so I have to work in quadrant 4. Okay, so that's the good news. So let's do it. And what we do is we actually draw a triangle in quadrant 4. Okay, now, if you look at this information, the tan of theta is minus √3. A cool trick that you can do is you can say minus √3 over 1, and it's still the same thing. Why do you think I wrote this as minus √3 over 1 and didn't leave it like this? Does anybody have an idea why I put the 1 there? Because I know that tan is a ratio of sides. So tan has to be O over A, or it has to be Y over X. Okay, but here's another problem. If I want to put this onto the length of my sides here, do you think Y is going to be negative, or do you think Y is going to be positive? Okay, so if Y is going to be negative, where does the negative have to go to? The negative, in this case, let's just see it's in the right place. 1. Okay, so in this case, if this is Y and this is X and this is R, the Y is actually going to be minus √3. Okay, and what is the X going to be? It's going to be 1. Okay, now, can you work out what the R is going to be? What is R going to be? What are you going to use to help you find R? So I think we use Pythagoras, and we say R squared is equal to 1 squared plus minus √3 squared. So R squared is equal to 1 plus 3. And so R squared is 4, therefore R must be 2. Okay, now, if I know the value of all of these, what is the value of the sine of theta going to be? What is this value of the sine of theta going to be? So think about what is sine? Sine is over h or y over r. What is that going to give me for this particular situation? Well, we said y is minus √3 and r is 2. So we get minus √3 over 2. So all that you have to do in this type of question is draw your drawing and then interpret it. Now, that is the answer for A. What about the answer for B? So I want you to try and figure out for me what is the value of 3 cos theta using the information in the drawing. So cos of theta would just be, let's think about it. So A over H or X over R. Now X would be 1 and R would be 2. So 3 times a half, or 3 over 1 times a half, is just going to be 3 over 2. Because cos is x over r in this particular drawing over here. Does that make sense, everyone? So why don't you have a go at this first question over here to see how much sense it makes? I will just give you this hint. It says the cos of beta is p over root 5, where p is less than 0, and beta is between 180 and 360. And all I want you to do is I want you to try and draw the drawing that goes with this, right? So I'm not asking you to answer it, but I want you to try and start drawing your diagram. And when you've drawn the diagram, say done in the chat. So I want you to try and draw the diagram all by yourself. If it's between 180 and 360, it has to be in one of these two. But now what is this bit saying? If p is less than 0, what is cos going to be? Is cos going to be positive or negative? Because it said p is less than 0, so p is negative. So then a negative over a positive is negative. And then I have to say, where is cos negative? Well, it's positive here, positive. So cos can only be negative here and here. What quadrant does my triangle have to be in? It has to be in quadrant number 3. So I draw my right angle triangle. Now what I want you to do is I want you to try and fill in the 3 missing sides of this triangle. And when you're done with that, I want you to just say Pyth for Pythag in the chat, because you're definitely going to have to use Pythagoras to help you figure out all 3 sides. So off we go. See if you can find the 3 sides involved here. Okay, this is actually a trickier one. Sorry, guys. I actually realized. Okay, what makes this difficult? What makes this more difficult than the last one? I'm going to give you a bit of extra help here. Would you agree that this should be P and minus P, and this one over here should be root 5? Is everybody okay with, yeah, you don't have the y. So if you don't have the y, all you need to do is use the p value that's there already. So if I want to now work out what this thing over here is, and I'm going to put the answer up so you can see it, but I'm also going to write it out. I'm going to say that square root 5 squared is equal to y squared plus minus p squared. And I'm just going to say y is over here because I don't know what it is. Now, if you think about what happens when you square root 5 gets squared, you get 5. And then you get that. Now, in order to get get y by itself, all I'm going to do is I'm just going to say 5 minus p squared is y squared. Okay. Now, what I'm going to do is, what do I need to do to get y by itself? Zwandile, let's go to you now. What is your question? Can you hear me?
Yes, sir.
Hey, how can I help?
Sir, in course, are we using in terms of SOHCAHTOA, are we using the cos or the tan?
Okay, so we are using the cos. And so the reason we're using the cos is in the yellow at the beginning. It says the cos of beta is p over root 5, but p is less than 0. So that's why I'm using the r and the x, or the o and the h. What I'm going to do is, this question is a little bit tricky. So I'm going to put the full answer on the board so you can just see it as I'm working it out. And that will help you a little bit as I show you what's going on. So if you look at finding what y is, all I'm going to do is I'm going to square root both sides, and that is going to give me what y is. But if you look at y, is y going to be negative or positive? If you look at where y is it going to be negative or positive? Look at where it's sitting. It's hanging out down here. Is y negative or positive? Okay, it's negative because of the quadrant it's in. And so this y value can be positive or negative, but because of where it is, it's just going to be negative. And that's why, if you look at the answer over here, you've got this bit here. Now, I'm actually going to allow us some more time to do another question, but all that you have to do in the step after this, right, is it says you need to find a value for the tan of beta. Now, if I want to know what the tan of beta is, all I need to do is write that the tan of beta is the same as O over A, or it's the same as Y over X. So you know what Y is. Y is just this value over here. And what is the X value? Well, the X value is just the one over here. So all that you have to do, let me just take that back. All that you have to do is you just put a straight substitution. So here's the yellow bit. And then over here, it's going to be, that should be P, okay, yeah, like that. And this, then for B, we haven't covered B yet today, so I'm going to pause at that stage. Okay, now that is a tough question, but the main thing I want you to take away is, can you work out what quadrant we're in? Can you then figure out the third side? And then from there, can you work out the value of an expression? Okay. Let me show you another, we've got time for one more question. So let's do one more question. I'll give you a moment to just take a screenshot if you want for this one. And then, yeah, so the P should be negative, although in this case, the P, they already say that is negative in the question. P is less than 0. Okay, don't worry about that. It's got to do with P being negative already. So Rekanisa, we can leave that discussion for now. It will be fine. Okay, let's look at one more question here today. Let's see if I can find you one to just kind of no, not that one. Okay, let's finish with these multiple choice questions. So let's do one. If sine of theta is negative and cos of theta is positive, then which statement is true? Which of the 4 options goes with this information? Is it A, B, C, or D? Which one do we think it is? This is using the idea of what quadrant we should be in. So when is sine negative? It's going to be here and here. When is cos positive? It's here and here. So it must be D as the answer. Because it's the only quadrant that does both pieces of information. Nice. Okay. From what I see in the chat, most students were comfortable with that. Let's try another one. If tan is negative and cos is negative, then which quadrant are we going to be in? A, B, C, or D? Where is tan negative? It's here and here. Where is cos negative? Cos is negative here and here. So it must be quadrant 2, which is B. Nicely done, everyone. Nicely done. So this helps us, like in the questions we were doing earlier, if we understand what quadrant has to be involved here. Okay, now I want you to do A. Is the sine of 315 positive or negative? Positive or negative? So that is going to be in quadrant 4. And quadrant 4 sine is negative. Yeah, all good. What about the cos of minus 215? Is that going to be positive or negative? Let me think about where minus 215 is. So that's minus 90, minus 180. So I'm in that quadrant, and cos is negative in the second quadrant. Yeah. Notice how that negative angle goes the other way around. Okay, what about tan of 215? Is that positive or is that negative? So 215 gets me here, so that's positive. And what about the cos of 390? What's that going to be, positive or negative? So 390 is the whole way around plus another 30, which is in quadrant 1, and everything is positive in quadrant 1. Okay. Everyone, if we look back at what we did today, we looked over the definitions of the trig ratios, and we looked at how we could put information on the cast diagram and how we could evaluate different trig expressions. We looked at how to use special triangles to evaluate trig expressions. We looked at how to use the reduction formula. And in the next lesson, we're going to start to move into trig identities. So we're going to use the reduction formula a bit more, and we're going to look at trig identities. Okay, but I hope that you enjoyed today's lesson.